In addition to the main theorems that we had for proving triangle congruence, things like SAS, SSS, all of those things, there's also a argument called CPCTC. So we're going to look at what that means and how we use it in proofs real quick. So this acronym stands for congruent parts of congruent triangles are congruent. So we got 5 letters and 3 of them stand for congruent. So we use that when we're asked to prove that two parts of a triangle are, and you might guess, congruent, because we use that word a lot. So that would mean either sides or angles are congruent. So first we have to know the triangles are congruent, though. So we have to know the triangles are congruent because that's the condition, right? We need this triangles to be congruent for the congruent parts to be congruent. So let's look at a couple of proofs for this. We have AB is congruent to AD, so we'll mark that here. BC is congruent to CD, mark that there. And then we want to prove that BCA is congruent to DCA. So we want to prove that these two are congruent, but first we'll need to prove that the triangles are congruent such that that angle falls at the same letter, at a corresponding letter. So first thing we can say is, I don't know if this takes all 5 lines or not, I haven't looked at this proof, so I'm going to go ahead and put both givens on one line, and we'll have an extra line when we get to the end. So we'll put AB is congruent to AD, and BC is congruent to CD as given. A lot of these pages, they do that as 2 different steps for the given, so we'll see if this takes 4 steps or 5 here. So we have those 2 are given, and then we want to prove that the 2 triangles are congruent. So I know that 2 sides are congruent, so my option is to get an included angle to be congruent, which is the thing we're trying to prove, right? So we can't use these 2 angles as congruent. Actually, wait, the included side, that would be angle B and angle D. I don't have any kind of way to argue that those are congruent. So the other tool I have, so we have SS. Remember, we're not going to use SSA in most cases. We can't use SAS here. So the only option left with 2 sides is side, side, side. So that means we need to argue that the third side is also congruent, and that's pretty easy because it's a shared side. So we can say side AC is congruent to itself by the reflexive property. And then we can make a congruent statement about the triangles now. And remember, to name them, it can help to just follow the marks we made for the sides, right? So the 1 mark, 2 mark, 3 mark would be naming this triangle ABC, and we'd say that's congruent to triangle. And then on this one, we'll also go around 1, 2, 3. So that would be ADC, right? Yep, ADC. So now we have our congruent triangles, and we got that by side, side, side theorem. Postulate, right? Okay, then we have these 2 angles need to be congruent, and we have that now because the 2 triangles are congruent. So we can say angle BCA, that's the 2nd letter, 3rd letter, 1st letter, is congruent to angle DCA, because that's the 2nd, 3rd, and 1st letter in order. And we do that by this new argument, CPCTC. All right, we'll do one more. So PS is parallel to QR. So PS is parallel to QR. That means we're going to have transversal things going on, so we need to remember to bring those in. Go ahead and put that here. PS parallel to QR as given. And it looks like they do want the givens on separate lines to fill out the table, so I'll go ahead and just put our other given, angle QPS, is congruent to angle SRQ as another given, and we'll mark that on the drawing. So QPS is this angle here, and SRQ is this angle here. All right, so let's see what we can figure. I'm gonna extend these lines a little bit so I can see my transversals. Remember that the transversal has to go across the parallel lines, so that means we have a relationship on the right side and a relationship on the left side, but not across the bottom or the top, because that's going along the parallel lines. So we need to look for something here and here that we can establish. So it looks like this angle and this angle are alternate interior angles using this diagonal transversal. Now, importantly, this one and this one are not alternate interior because they would need SR and PQ to be parallel, which the way it's drawn, it looks like they are, but we are not allowed to assume that. So we can't assume these two X angles are the same. But we do know now that this angle is the same and this angle is the same. So with two angles, we can't use three angles. That one's no good. So we need a side, and it can be either side, right? It can be the included side or a non-included side, and that's going to give us one of our congruence rules. So again, just like up here, we have a shared side right in the middle. So looks like that's I can't see anymore, SQ is going to be congruent to SQ because it's reflexive, it's the same side. So then we have two angles and a side. It's not the included side, so we'll call that AAS. And our congruent statement, so the way I'm going to write it, I'm going to start at the 1 mark corner and go toward the 2 mark corner. So here I'm going to go PSQ, and that's congruent to, start from the 1 mark, that's R, go toward the 2, RQS. I'm still going to end up one short of the lines because remember, oh, I didn't actually write the one to say that they were alternate interior. So that's what's missing. Whoops. Well, we'll just pretend that step 5 was back here before we made our congruent statement. And it said angle PSQ is congruent to angle RQS by alternate interior angles. Okay, now we're good. So now we can say that the triangles are congruent. We've said the triangles are congruent, so now we can say that the congruent side PQ, which is the left, is congruent to RS because PQ is the first and third letter, RS is the first and third letter. So PQ is congruent to RS, and again, our argument is CPCTC. So that's how we use this tool. It's basically just like triangle proofs, right? So we did the congruent triangle proof to get down to AAS and say the triangles are the same. This is just one step further to say that then another part of that triangle is congruent to its corresponding member of the other triangle, because we know once their triangles are congruent, everything on them is congruent.